Again, my name is Žorž from Internet Society. I'm coming from Slovenia, and this time I will speak on behalf of Internet Society. Thank you, Champika, for laying out the foundation of the DNSSEC, so I will not have to explain everything from ground up. And I will talk more about the operational experience and some experiments that I did in my lab. First, a little bit about myself and why there is Go6 sign in there. I'm the founder of Go6 Institute, the IPv6 initiative in Slovenia to deploy IPv6. And as a part of Go6, we built the Go6lab. That's a room with 3 racks of equipment where we are performing lots of IPv6 testing, experiments, testing of hardware, testing of software, and testing of everything. And being involved with IPv6 for like 18 years, you know, IPv6 is getting deployed. It's getting easy now these days. It's supported in hardware. It's supported in software. You know, people is deploying it. No big deal. These few new things that are coming out, we test it and we're done, right? So I got bored in my lab. And you will hear this a lot, how I get bored in my lab. I was sitting there and thinking, I have all this equipment, and now IPv6 became a little bit boring. What to do? And I said, okay, I hear a lot about this DNSSEC. But in my mind, it was sort of like, this is really complex. This is really complex, because I was reading all these academic papers and all these blog posts about all this complex stuff that's going on in DNSSEC, and I said, you know what? Let's go and figure it out. But my brain works in a way that I don't learn things if I don't test them, if I don't put them on my server and configure them. Just by reading I don't understand how it works. So, first of all, the acknowledgement. I would like to thank Internet Society that they let me spend lots of my working time in Go6lab and actually test all this stuff and set up all this equipment and environments. So I would like to thank ISOC that they allow me to do all this stuff and make internet a bit better and more secure place. Okay, so how did it all start? I got a challenge from Matthijs Mecking. Back then, he was working for NLNet Labs, and once we were talking about some stuff at the IETF meeting, and Matthijs asked me, Jan, why is Go6.si not signed with DNSSEC? And I said, because it's too complex, because I don't know how to. And I said, if you, as the developer of the OpenDNSSEC platform, if you are willing to write me a document that is operational document, very down to earth, okay, take this, install this, configure this, this is how you add the domain, this is how you publish the DS keys, then I'll do it. And this guy actually wrote a very, very good, like 4 or 5 pages, very precise documentation how to actually implement the whole thing. So I took the document, and I went through the document and I put it to the test. All right. So I decided on PowerDNS server because PowerDNS server was something that I was running as a primary DNS server for the zones anyway. And in this case, it became a hidden primary DNS server. Then I put in between the OpenDNSSEC platform that you probably all know and heard. It's an open one, it's a free one, and it's quite well done. It's a little bit non-friendly to set it up, but if you have good instructions, all is fine. Then I put the Bind9 and PowerDNS servers for the resiliency and the diversity purposes as the secondaries to OpenDNSSEC to serve the signed zones. All this is created on the virtualization platform for servers. It's Proxmox 4.4. And the OS templates that I used were Fedora 20 because OpenDNSSEC is quite well maintained on Fedora, and CentOS 6 and 7 because I just like it. All right. So you see here, this is a bump in a wire situation. So I have two public primary servers that are on the internet-facing side, and the concept is I don't have the laser, but the hidden primary, I added the zone there, and then it is sent via the DNS transfer mechanism to OpenDNSSEC server in the middle. It is signed there, and then the OpenDNSSEC server sends the notify to the two servers that are public-facing servers, and then they start serving the signed zone. It's that easy. Okay. Oh, thanks. Thank you. The first one. Oh, it doesn't go that. Oh, it goes that far. Okay. So you will have to look back then. All right. So that was fairly easy. It works. Here is the link that you can use. Download this PDF, read it. It's very simple. Just follow it, and all of a sudden you will have OpenDNSSEC, and you will have the zones that are signed with OpenDNSSEC. Now, lately, I also signed the DNS zone on a hidden primary. So I used the Power DNSSEC zone signing functionality for a test, and just went around the OpenDNSSEC platform as an alternative solution, and it works fine. So far, I think Pragma.si is signed with directly on the Power DNS, and so far so good. All works. All right. So I published the DS keys to our TLD, to .si. Everything worked. I went through all this DNSSEC testing and analyzed them with DNSVs and all this stuff. Everything worked. Everything is fine. Everything is brilliant. Now what? And I was again sitting in my lab, bored. Like, okay, now I have DNSSEC. What can I actually do with it? And then I said, okay, there is this DANE thing that people is talking about. And this is all about verifying through the DNS the authenticity of the SSL certificates that we are using to encrypt email, HTTP traffic, and things like this, right? So I said, okay, DANE looks cool, and it requires DNSSEC. Otherwise, if you don't have the trust of the DNSSEC, you cannot verify the certificate on the other side. So, of course, because currently the browsers, the web browsers, do not have built-in DANE validation support because of various reasons. Some of them technical, some of them political. I decided to test DANE for email, right? It's a service. And Postfix comes with a TLS support, and it also comes with a DANE support, but the version of the Postfix servers needs to be bigger than 2.11. You don't have DANE support in versions lower than 2.11. So we decided on Postfix 3.0.1. That was the cutting-edge development version back then. Nowadays, we are using 3.1. It's the release, and you have full DANE support with all whistles and bells that comes with it. So what is DANE? DANE is basically a TLSA record that you add to your zone. And if you see here, the TLSA records, for example, for mx.go6lab.si, that's my MX server. That's my mail server that receives all the email and sends all the email for my lab. You can see the format of the TLSA record. It says _25, that's the port, _TCP, that's the protocol, and then the host name. So that means if you receive the certificate over a connection that is made over TCP to a port 25 to this host, you can verify the hash of the certificate. Then you see it's in and TLSA. TLSA is a type of the record. Then you have 301. This is some sort of selectors. This selects how you want to use it, what are you publishing, and what is the format. You have everything specified on the internet how this works. So this is a selector. But then you see a row with some random numbers and letters. This is the actual hash of the certificate that I am offering to everybody that connects to my server and wants to send me mail, right? So you can read more about DANE at Deploy360 resources, but here is how it actually works. So somebody wants to send me email, and they establish a connection, and then I say start TLS. That means I can do TLS, and I send back the TLS certificate. Now the other party, the party on this side, it asks the DNS server, their resolving DNS server, and says, okay, does this host have a TLSA record? And then the DNS server asks my DNS server or the global DNS system around the world and says, is there _25._TCP.mx.Go6lab.si, is there a TLSA record existing? And my DNS server sends back the response. And it says, yes, we have a TLSA, and this is the hash of the certificate that you should be expecting on the session with the email server, right? And it validates with DNSSEC because it needs to be trusted, right? You cannot send just whatever. TLSA record works only if the zone is DNSSEC signed. So when it's verified, the DNS says to the sending server, it says, hey, yes, there is a TLSA, here it is. And then the SMTP server that is sending email just looks and says, okay, I received the certificate from this guy, that is this. The TLSA says, this hash, does they match? Yes. Okay, now I believe that this is actually you, that this is not somebody in between trying to get in the middle and try to decrypt traffic and sniff traffic and do bad things, right? And it is all published in DNS. So you can have self-signed certificate. You don't have to pay for it. And if you verify it with publishing the TLSA record in the DNS, that's good enough. You don't have to have a trusted certificate. That's why some people is becoming a little bit nervous about it, because they're running big businesses on the trusted certificates, and this is actually removing that need. So okay, now we know that we are sending email to the real recipient, right? So I figured out how easy it is. I published the TLSA records. I set up the Postfix with all whistles and bells to do DANE verification. And then I asked some people around, some of my friends, okay, who is able to verify from the remote that everything is working? And you see, first one was from my friends at T2. This is the operator in Slovenia. And they said, yeah, you see, verified TLS connection There. Verified TLS connection established to SMTP at T2. That means that they were able to verify over the DNS that the certificate that I'm sending to them is valid. The next one was people from NLNet Labs, Ben Overreinder, sent me a copy and paste of the log file saying, hey, Jan, I was able to verify your stuff. So this is the Postfix config. If you want to do this, you just need to, there are some programs there are some small scripts on Linux, how you generate the TLSA record. It is also possible online. There are some online mechanisms that you generate TLSA record. And if you're running a Postfix, newer than 2.11, this is the config that you need to put in. That's it. How hard can it be, right? And it just works. And then I got bored again. I was just sitting in my lab. I have this chair that rotates, and I was rotating around. Okay, now what? I said, okay, let's see if I am alone in the world using DANE on email. Okay, my friends at T2 and NLNet Labs are using it, but let's see if I'm alone. So I said, where should I take the source of my little test and experiment? And I said, okay, top 1 million Alexa domains should be the right source. So I fetched down the top 1 million domains and created a script that actually sent an email to each of these domains with basically should be non-existing email address of test-dnssec-dane at each domain. So I basically sent 1 million emails from my lab. Okay, I'm not a good programmer, so I had few glitches in the script, but after some tweaking, I got some good results. And then I built the script that actually parses the Postfix log file and extracts all the information, what actually happened with these 1 million emails that I sent. Well, nearly sent, because majority of them were just non-existing, so the session was cut there and not delivered, but the point was on the first part. All right. And here are the results. So out of 1 million domains, majority of them had an MX record and mail server. Okay, I will go a little bit back. Out of 1 million SMTP sessions, what is your prediction? What is the percentage of the sessions that was encrypted of any kinds? Encrypted, non-plain text. Any takers? Any number? 5%. Okay. I need to disappoint you. 70%, 70% of all attempted SMTP sessions were encrypted. Our friends at NSA are not very happy with this. I can tell you, 70%. I was shocked. I was sort of like, wow. I was also expecting like 5 or 10%. But apparently, all these mail servers comes with TLS enabled by default. They just generate self-signed certificate. And whoever on the other side is able to encrypt, they're encrypting. So maybe you are already getting lots of encrypted emails on the transport and you don't even know. But this is the result. Okay. So majority of TLS connections, 60%, were established with a trusted certificate. That's another shocker. That's actually people paid money for the certificate. And of course, some of them, 1,382, announced TLS capability, but failed with cannot start TLS handshake failure. These people will never get email from me. Believe me, never. because the mail server doesn't work. Okay, more results. So you have anonymous. You have different levels of trust of encryption. Encryption is the same basically. Encryption is encryption, just different levels of trust. So anonymous is opportunistic TLS with no signature. That was 109,000 roughly. Untrusted, that means self-signed certificate on the mail server was 167,000. Trusted, 410,000. And verified, 128. Yay, this is DANE. Verified means that the certificate was verified with TLSA put together and matched. So I'm not alone in the world using this stuff. 128, and I must say majority of them were in Germany, because in Germany there was some push from the government that people should start using DANE. So lots of them in Germany. All right. So what was the mail distribution? Google.com had lots of domains, 125,000. Then you have secureserver.net, QQ.com, Yandex.ru, OVH.net, and all these big mail servers that are carrying quite a number of domains. You can see the TLS states, also trusted, no TLS, trusted, anonymous, so different things. But the problem is that none of these big mail servers are DNSSEC signed. And up to January 2016, that meant no DANE for them. Now, technically, it is possible to do DANE also with these non-signed domains, but we will see later how this works. It's a little bit of a hack. It's not all the way secure, but it can be done. It's better than nothing. Let me put it this way. All right. And then I got bored again. Like, okay, now I understand I'm not alone in the world using this stuff. What can I do now with this? DNSSEC is working, DANE is working, people is verifying my mail server and the certificate. Now what? I said, okay, let's see how far do I need to push DANE for it to break? What are the corner cases where the thing stops working? I said, okay, let's publish the malformed TLSA record. So if I change one character if I change one character in a certificate hash that is published as a TLSA, what happens? And I set up another set of mail servers for sending and receiving and testing. And actually, Postfix failed to verify it and actually refused to send the message. So what it did, it said, okay, I need to send a message there. There is a TLSA record. Got the TLSA record, tried to compare both of them, and you see, untrusted TLS connection established to mailbed Go6lab.si, server certificate not trusted, and it actually dropped the connection. So, yay, DANE actually works. So if somebody would want to get in the middle and say, hey, I am Jan's server, and this would not match with the TLSA certificate in my DNS system, he would not be able to get the email. That's good. That's how it's supposed to be. Okay. Where else and when do DANE things fail? Of course, with wrong certificate hash, refuses to send an email. But then if the domain where MX record resides is not DNSSEC signed, can't trust the data in MX, so no verification, of course, because you can't trust the data. And if TLSA record published in non-DNSSEC zone, can't trust the data in TLSA, so no verification. Now, you will have to bear with me, because this can become a little bit complex now, right? Follow closely. Example. So Go6lab.si zone is signed, and so it's mx.go6lab.si as an entry. And there is a TLSA for mx.go6lab.si. It's also signed. So domain, so this is just as an example. Signed.si is signed, and mx in that domain points to mx.go6lab.si. So if you send email to jan@sign.si, the mx is signed and it's pointing to the TLSA that is actually signed. And then you have domain non-signed that is not signed, and you have mx record in there that also points to mx.go6lab.si that is actually signed and has the TLSA record. And when we send an email to jan@sign.si and jan@notsigned.si, what do you think will happen? Any ideas? I see puzzled faces here. Okay, when I send an email to jan@sign.si, of course, it will say verified TLS connection established, because the zone where mx record resides is signed, and the zone where the A record that mx is pointing to is also signed, and TLSA is there. So this is good. But when I send email to jan@notsigned.si, it says anonymous TLS connection established, because the server got the mx record that is not signed, and the DANE process just exited because it said, I don't trust this data. So despite the fact that it is pointing to a destination that is DNSSEC signed and has TLSA record, it does not verify, because it says, I don't know if I should send email there. But my point of view was that if you can verify, please at least verify the destination. You don't know if the path is correct, if you are supposed to send email there. But if you don't verify even the destination, you will send email there anyway, right? So why not using the opportunity to verify the destination? So we had a long discussion with Viktor Duchovny from the Postfix developers, and actually at the end he fixed the Postfix. So now there is an option that you can say to Postfix, verify the destination despite the fact that mx record is not trusted. Okay, of course. Another way how not to do it is if you point mx record from signed domain to A or quad A record that is in non-signed domain and has the TLSA that is also not signed, and that will not work. That will just DANE process will just exit and say you're on your own. Yeah. So this was the Postfix improvement in January 2016. When Victor sent me, hey, Jan, we implemented this and fixed, so now you can verify the destination despite the non-trusted mx record. And then I again got bored in my lab. It's like, okay, what else we can do with this stuff, right? And then Let's Encrypt came along. How many of you is using Let's Encrypt? Just Maz? So, do you know about Let's Encrypt? It's the CA that is issuing the SSL certificates for HTTPS, for email, for anything, for free. It is completely free, and it's trusted. It was set up based on Mozilla Foundation, and also other partners came together and said, we would like to set up a thing that you can get free trusted certificates that are cross-signed, so your browsers are all green and everything else. So, of course, I put on all my servers, I put Let's Encrypt certificates because they're free and because I can, right? There is an API that you just set up and it will renew everything and do all the work for you. So Let's Encrypt. So then I asked, okay, Let's Encrypt certificate is trusted. It is signed by a cross-signed entity. But still, somebody else can, some other CA, because there are many of them, can issue the certificate for my domain or for my host and sign it. So you will have two of these certificates out in the wild, and now which one is correct? So why not putting TLSA record in my DNS, so people will be able to verify which one of them is the right one. So I said, okay, let's encrypt and cover it with DANE and set it up for email. So Let's Encrypt recommends using 211 and 311 records. You will learn what this means. One is basically the end certificate, and one is the signing certificate. But the problem is that validity of Let's Encrypt certificate is 90 days. And by default, the underlying key is changed. So every time you renew your Let's Encrypt certificate, by default, they change also the private key, out of security reasons, I suppose. But if this happens, when you renew the certificate, the hash of your certificate changes. That means you will have to change the TLSA records every 90 days in your DNS server. And that if you have thousands of domain, that just doesn't scale properly. So I decided to publish the 211 method, but the 211 method that is actually publishing the hash of the signing certificate. In this case, it's a DST root CAX3. Let's Encrypt client does not put their certificate in full chain. So I need to do a little hack to add to it. You will see how. So, but nevertheless, I'm using 211 and 311 for the same host. So in case something happens, one of them will cover my domain. So if we want to publish to 211, then we need to fetch the DST root CAX3 certificate and add it to fullchain.pm, and that is my dirty hack. It's very simple. You just fetch it with links, set it and awk it and add to your full chain file, and you're done. It is very simple. Okay, when I did this, so this is the verification application that is on the internet. You can say, please verify DANE on this host, on this port, and it fetches the certificates, it fetches the TLSA records, and it says everything is green, everything is fine, you are good to go. But at next certificate renew, by default, the underlying key will change, and the TLSA will become invalid. So, labor-wise, we need to keep the underlying key through the renewals. And I found the --CSR option in Let's Encrypt Auto Client, and in directory examples, there is a generate csr.sh file that you actually create the certificate request that will stay over the renewals. And this is how you generate a certificate, and then you have the one that you can use with this command that you see below. Okay, so now we are using the same underlying key for automatic renewals, and we will rotate the underlying key when we decide to. It will be human assisted. When I decide that the private key is not safe enough or is not secure enough, then I will just rotate it and change all the TLSA records and things like this. Now the whole thing was updated to certbot from Let's Encrypt certificate. And of course, we still add the DST root CAX3 certificate to full chain, and the whole thing is completely automated, and I don't have to deal with it anymore, and it's just auto updating. Now I even wrote the scripts that dynamically updates the DNS server. So if the TLSA changes by any chance, my script will do the dynamic DNS update to my DNS servers and actually remove the old TLSA and put the new one in. And as you see, everything is green, everything is fine, everything is working. Here is more reading. We wrote 2 blog posts on Deploy360 where I described all that and the process and everything else. So here are the links. I believe the presentations will be available for download. It's a nice reading, and with the secret hope that you understood everything. Are there any questions? Don't look at me like an alien. No? Okay, then in this case, thank you very much.